Hello guys, Nitin here. This is the second part of our video. So we are designing this G+14 building. In previous video, I have assigned all the properties and I have applied the load conditions also. So in this part, you will see how we will analyze and how we will check. Okay, so you can see here the maximum deflection there. So it is in meters, so I converted in the millimeter. So go to the consistent unit and sorry, this is in inch. Okay, so force unit in kilonewton, temperature unit in Celsius. Okay, that was in Fahrenheit. So click OK, and after that you will see all the results in the mm. Yeah, you can see the maximum deflection is 21 mm, so it is failing. Okay, so as per IS code, the allowable deflection is 20 mm, span by 250 and the 20 mm. So the maximum deflection should not be more than 20 mm. Okay, as per IS 456. So we will increase the member size. I have taken the member size for the column is 450 by 450, and so now I will increase the member size of the column, and after that we will see the result. Okay, so you can see there is a maximum deflection there. You can see here the maximum deflection. There is a no column in between that. In between that. Uh, if you want to increase the column, so you can increase. If you don't want to increase due to the aesthetic purpose, so you can increase the size of the beam also. Okay, so if you don't want to have columns, you can increase the size of the beam. So now I will check the results and go to the force slash stress diagram. So here I will go for the frame bias spandrel links forces. Okay, so here I will see the maximum bending moment. Okay, so you can see here the maximum bending moment. You can check the bending moment, WL square by 8. Okay, so and here the shear 2 this structure is very big, so it is taking time when we press any key, any button, so it takes a little bit of time to show the result. Okay, so you can see the each and every beam result. So here the shear force is increasing in this part, and you can check the axial force also. And actually I have not taken the load combination. So in the when I will change the column size, the beam size, then I will take the load combination also. Okay, so let's unlock it, and first we will change this size of this column, because the diameter of the column we have taken the I think 24-inch, I think so. Let me check it. Yeah, 24-inch, so I increase it to the 30-inch. So it is in the meters, so you can type here 30 and the inch sign, so it will automatically convert in the meter. Okay, and okay now, and I will take the load combination also. You can take the manual load combination as per the IS 1893. You can type here like 1.5 DL plus LL and 1.2 DL plus LL plus EQX earthquake load, EQX and for the EQY, and you can take 1.5 EQX and 1.5 DL plus EQI, and you should take the in the plus and minus, okay, and after that 0.9 DL plus 1.5 EQS, okay. So I am going for the auto load combination. It will automatically take the load combination as per your code, okay. So you can see I was talking that was all the load combination are here. You can read it you can read it by selecting this and modify show. You can read, okay, and these load combination are as per the IS code. So now I will go for the wind load also. So press here wind in the X direction. After that we will check the result of, after that we will check the displacement and the result. The wind load is as per IS 875 part 3, here 875 IS 2015. There are the two, because it's a previous version IS 875 and 1987 it's a new version, revised version, okay. So click here in the X direction, in the Y direction, click here, so modify it. And so I am living in Delhi, so here the wind speed is 47 meter per second and terrain category is 2, okay. So here terrain category is 2, so importance factor I am taking 1.15, and the risk coefficient I am taking the 1 because I want this building for the 50 years, and topography factor is 1 because this there is a no any slope, okay. So it's a less than 3 degree, and I want the wind load for the top story. I don't want it for the parapet, and for this I'll have to assign the diaphragm also. So click OK, and the wind on the Y direction. For the Y direction, click here 47 and 10 category 2 impulse factor 1.15, and you have to take here 90 degree. Okay, for that you have to take the 0 degree. Okay, so click OK and done. And now let me check is it changed or not. It is showing 24. I know because I have not changed the name of that column which I have changed the property. Okay, so go to modify and click here 30 inch, okay. So click OK. Okay, so now we will go for the analysis part. Before analysis part, first we will check the result. If it is failing, then we will do the response spectrum analysis. That's the dynamic analysis. After that we will do the response spectrum analysis, okay. Actually we should do now, but I want to check the result, okay. I want to check the result, okay. When the building is more than 15 meters, then you should do the response spectrum analysis, and when the time period is more than 0.4 second, then you should do the response spectrum analysis. So I am taking the time period for the calculation. The software will automatically calculate because it will give the accurate data. If you provide the if you manual add the time period as per the IS 1893, that is 0.09 divided by under root LX and LY for the different direction, so that will not give the accurate data. So it will be so we should so software will automatically calculate and that will give the accurate data, okay. So go for the analysis part, run analysis, okay. So run analysis, it will analyze the model. So it will take a little bit of time because the structure is very huge. So mm, I hope you guys are liking my videos. So all the parts, I think you have seen the previous videos also for the designing of the bridge and the warehouse. For the previous videos, you saw that yeah, the twisted building modeling part. Okay, so I am analyzing. So you can see the this model is being analyzing by the Etabs software. Okay, it is taking our time, and 2% is completed. It is taking time. After that, we will see if it is failing or not. Okay, so 17%, 91% is completed. You can see in the corner, top left corner, and in the run analysis. After that, we will see if it is failing in a deflection. Then we will see if it is failing in the displacement also on the wind load I have planned. I will see if it is failing in the displacement or not. So you can check that by 500. Okay, by 500. Okay. So it is a formula for checking the displacement in the vertical displacement h by 500 for the wind load. For the earthquake load, h by 250. And so for the deflection, you can check the span by 250. For the long-term deflection, you can check the span by 350. Okay, and for the bending moment, you can write these formulas. For the bending moment, we check the bending moment like W square by 8 and the shear for W square by 2. This bending moment is for the continuous beam. Okay, for the slab also we can check the bending moment span by 250. So it is taking time. This project is taking time. And so I hope you guys are liking my videos. So please share this video, and I hope you will get the knowledge from my side. It, it is again analyzing because it analyze the 2 to 3 part, analyze in 2 to 3 part. Okay, if you don't have the Etabs software, then you can comment me. I will upload the video for the downloading the Etabs software 2016 version. If you don't have, you can comment down below. I will make a video, so after that you can download it. Okay, so and this is the from my side, and I think now it will be completed. Again, it is analyzing. I don't know why it is taking so much time. Yeah, you can check the result. You can see here. Now it's a 19 mm. Okay, so now we will check the display and go to the story response plot, and you can see the maximum story displacement. Here you can check the drift also. First I will go for the displacement check for the wind load calculation. in the X direction. So maximum displacement in the X direction, it is not showing. I don't know why. Maximum, oh, I think it is not showing because I have not assigned a diaphragm to the building. So it will, so leave that, and I check for the maximum story drift in the X direction. Earthquake in the X direction. Yeah, it is showing. Yeah, you can see the curve like this because it is failing in the equivalent static analysis. We'll have to do the dynamic analysis. So it is passing, and the value of the drift should be less than 0.004. I think it's passing, but it requires the dynamic analysis. In the y direction, you can see whether it is passing or not. Yeah, it's showing in the both 0.001. Okay, it's passing. So for wind load calculation, first you'll have to assign the diaphragm. Then you can check the diaphragm displacement. Then it will show the displacement. Okay. And I go to the topmost story and I check here the displacement, lateral displacement for the earthquake analysis. You can check by span by height by 250. Yeah, in the UX and the UY direction. I think it is passing in this also. Okay, so that's for this video, and that's for now for this. And for in the next video we will see the response spectrum analysis. Then we will check the result also. We will compare the result in the earthquake and the equivalent and the dynamic analysis. Okay, so that's for now. I hope you are liking this video, and don't forget to subscribe and like this video and keep spread, because if you don't spread, then how will I make? Okay, so please share this video to your colleague, to your college mate, to your bench mates. Okay, so thanks for watching this video. In the next video we will do the dynamic analysis.